Okay, yeah, let's start a bit earlier. So first of all, please, if I'm too fast or if something is unclear or you have a short question, interrupt me and yeah, I'll try to answer the question right now. The title of the talk is From Zero to Web Scale, Automating Digital Growth with SaltStack, and it's a project where we use Salt now since almost 3 years, where I will report on how we evolved our CI/CD pipeline from something very simple at the beginning to something a bit more complex right now. And yeah, before we start, let me just shortly explain how the talk is structured. The main part will be where I describe how we evolved our pipeline, followed by some remarks and conclusions. But first, I want to introduce the context in which all this took place, the challenges and the technology. So some words about myself. So my name is Martin Hofling. As you can see with the last name with the 2 funny dots, it's a German name. I'm consultant at TNG, Technology Consulting, and my project is consulting a startup company, which is quite uncommon, at least in consulting. And my original background is actually physics, and with that I'm not alone at my current company. TNG has roughly 230 regular employees. Over 50% with a PhD, and also physics is the strongest field in there. We also have mathematicians and computer scientists, but physics I think is at roughly 30% or so of us are physicists. The company has been founded in 2001, has grown roughly 25% every year, and the place of business is Munich. So all our projects are also in and around Munich or greater Munich area. And the focus is high-end IT. So yeah, startup is a very special field for a consultant because it's not the typical enterprise setup that you'll find. And there are some special challenges. So the first one is that you start with very few people. So when we started the project, the prototyping, we just had 2 consultants and the founder of the startup working on that. And yeah, on the other hand, you have just the motivated tech addicts, so that's the upside with a few people. Often the target is roughly clear, but the way to that is not carved in stone. So you can, or you often even have to adapt and quickly change directions, and that's possible because hierarchies are also pretty low. So you just walk to next door and can get a pretty fast decision on a change or on an idea that you have. And also, what is quite special in such a setup, in contrast to a typical enterprise setup, is that you have no dedicated operations. So you have to do all your stuff yourself. So, and as such, also it is at least desirable that everybody in the team does development and deployment, and thus also operations. So that's the ideal picture. Yeah, I'll describe a bit on what the challenges are. So. The product is, if you simplify it very much to the essence, classical web application. You have users that talk via their browser to the backend, and the backend talks to the database. So that's very simple. Unfortunately, there are some challenges, and the 2 main ones are that in this case, we need to be able to scale first to high numbers of users, and then we also need to rapidly react on changing numbers of users. And the second challenge actually is kind of like a result from the first one. The whole thing is not as simple as on the first picture. Instead, we have several different types of backends for special purposes. We have several databases. And on top of that, we typically deploy daily also, and also very often, so not daily, but very often we also have changes in our infrastructure, which we want to incorporate during a deployment. So just to set you up, the technology that we're using, one can roughly organize into 4 different fields. So let's start with a boring one, front end. Yeah, we're using React, Webpack, so all the hot shit on the front end side. The backend itself is written mainly in Python, so we're using Python 3.5, and our web application server, if you want to call it like that, is Tornado. We're using some NoSQL databases, MongoDB, Elasticsearch, Redis as a cache and key value store, and also for PubSub. And then the more important part for today is what one can roughly summarize as cloud technology and infrastructure. And on the infrastructure side, we have many things that you would also find like in a normal installation, like Isinga for monitoring. We use Jenkins for continuous integration and deployment, Packer and Docker. On the cloud side, at the moment at least, we're using AWS and Boto 3 for automation, also partly for the parts that we don't automate with SaltStack and Terraform. And SaltStack is really in the middle here because it's actually the glue that holds, at least from the deployment side, the things together. So the evolution that we had, one can roughly split into 3 phases. So at the beginning, you have to learn. You start up and you just have to set up everything, and you typically start simple. At the beginning, you just don't start with a distributed system and 5 services, but probably with 1 or 2 at the beginning. Once you have done this, our second phase, I would say, if I look back, was the part where we automated the deployment in such a way that you really can click on the deploy button and you have your and you specify a version and you have your tested version deployed on a system. And at the end also on a distributed system. And the third part is you have a lot of infrastructure around that you don't modify during a deployment. So that's what I would call kind of like static infrastructure because it's not touched during the deployment. And I'll describe at the end how we also automated the provisioning or the definition of that kind of infrastructure. So the first thing that we typically do, so we all have a software development background, so CI, continuous integration, is very important to us. So setting up a CI pipeline that gives us automatically tested code and the artifact that we can deploy is very key and was actually also the first step that we did. Also, what we get there is a deployable artifact, and the thing that you want to do also at the beginning is, since you want to showcase your applications somehow, you want to deploy it somehow, and also somewhere, and it should be reproducible. So ideally, it should be doable with some commands, maybe not, which are not maybe executed daily at that point, but you don't want to hassle too much with that. And when I joined the project, the setup looked very simple. So we have our developers. The developers push their commits via Git. The CI ran on a single server, which had a Jenkins installed on it. The artifact is just a build result of a Jenkins pipeline and can be pulled from the developers. So the developers took it and deployed it via SSH and some Puppet manifests, and that was great for the first 3 months. Then we figured out that, first we don't like Puppet, and the other things are also that this will not scale. I mean, you can do that with some single machines, but if you really want to orchestrate multiple machines, it will not be the tool that we stick with in the future. So we looked a bit around, and this decision, this is SaltConf, so decision was Salt, and the 3 main points. The 3 main points are here. The scalability was definitely very important, but for us also the event-driven configuration paradigm is very appealing because you have many services that are able to scale. For example, you have a database with replicas that you want to be able to dynamically increase, or a sharded setup that you want to be able to dynamically increase. And there it's very nice if you can react on events at some point of your infrastructure from another point of your infrastructure. And we definitely wanted a way to declaratively describe our configuration. I'll come to that point later. So 3 minor points which were also very important for us and made the decision much easier was that we did not want to decide on which cloud provider we want to stick on at that point. So Salt is agnostic considering the cloud provider. We're a Python shop, so nearly all developers had already more or less a Python background. So even for a person which is not involved in daily, in evolving the infrastructure and the automation, can easily extend some Salt modules or fix problems there. And yeah, also the friendly and large community around at that point was also a big plus. Yeah, so this is how our infrastructure looked after having introduced Salt. So not much has changed. So the artifact stays on the CI machine, and instead of having the developers manually connecting to the machines, they connect to the CI machine and use the Salt CLI from that machine to deploy on a test instance or the, at that time, single production machine instance in AWS. Okay, so wrapping up that phase, what we had to learn very painfully at the beginning, and luckily it was at the beginning, is that it's really important that you keep production and testing as much in sync as you can. So if you don't do it, then find a good reason and always also consider what could be the problems that arise from that. And we stumbled upon that a couple of times later, so that's an effort that one should take pretty early, also to spread it in the team, that this is an important point. Also, the main advantage from automating it at that point was not really that we gained a lot of effectivity at that part. I mean, an SSH deployment would have been as effective at the beginning, but we learned the tool, and you make a lot of faults at the beginning, and doing that with a simpler infrastructure also makes it less problematic to fix those faults later on. Yeah, and the third point is that you make the deployment also accessible at a point where it's small enough that most of the team can still understand it. So, yeah, let's move on to the second phase. So automating deployment to the cloud. So far, we have a single cloud machine. Not so special and cloudy at the moment. So, a very important thing when it comes to cloud infrastructure is that you consider cloud machines as cattle and not as pets. So I think it's a very known saying from Bill Baker and Microsoft. I think it's the original attribution. And so one should be prepared that they die and that one has to replace them quickly. And with that mindset, also the rest of the infrastructure was built. And there are three main things that we stick to in that phase. So the first is that we automate everything that affects deployments. So we really want to have our deployment a single button that you push, and ideally, if everything works well, everything is automated, and you don't have to touch something by hand. There are a lot of other steps, like set DNS entries, or you have maybe a CDN set up, which does not change during the deployment, and those things be set up manually at that point. And the third important thing that we did actually first was, okay, so we will probably change our CI/CD pipeline quite a bit. So we wanted to modularize our CI/CD infrastructure, that we can easily adapt and try out new ways or to improve the deployment of our application without breaking the current deployment pipeline. And our way to do that was combine Jenkins, which we already had, with Docker. So we Dockerized our Jenkins, and we gained exactly that flexibility. In addition, we have with that combination the flexibility also to easily replace CI hardware. So when you run on multiple CI machines and they are basically abstracted via the Docker daemon, you can easily move from one to another machine parts of your deployment without affecting it, and replace a machine, for example. What you also gain is transparency. So all our tests run into Docker containers. This is in particular nice for the integration tests, because they spin up their database Docker containers that they need, and you can run them in parallel, and you can run them locally exactly the same way as they run on the CI. And the third thing is, if you have enough built infrastructure, you can just parallelize your tests. And so I think at the moment our pipeline runs something like 4 minutes with end-to-end tests, so that's really, you get a very fast feedback on such a CI setup. And yeah, so the setup actually then looks like that. We have our bare metal hardware where the Docker daemon is installed, and the CI itself are many Jenkins Docker containers, actually one minion on one slave on each one Jenkins slave on each physical machine, and the Salt master we also put into a Docker container. And when we now push our code and get our build started, we just fire up, I think at the moment, something like 100 Docker containers for all our tests. And once these are completed and have produced an artifact, we just destroy them, throw them away, and can then, for example, trigger via the Jenkins pipeline the deployment, which uses the Salt master container attached to the CI to deploy the artifact. So how do we create a new machine? Yeah, and since we're on SaltConf, the obvious answer is Salt Cloud. Yeah, and that's can be very straightforward, implemented in right here. So we already have Salt installed on our Salt master. It already has the right version pulled from Git for the correct application instance, and we just use the Salt Cloud command on the machine in case that we need to spin up a new machine. Okay, so. So far, just one machine per application instance. This definitely doesn't scale, and is also, if the machine dies, it's not available anymore. So those are the two main reasons why one wants to move to a distributed application. But this comes at some cost. So definitely complexity grows once you leave your single machine setup. So you have to orchestrate multiple machines. You have to trigger the right reactions on another machine, for example, completing some job, and so on and so on. And this, of course, is additional complexity that also has to be managed somehow. But let's first step back on how distributed application is actually created. So you don't have the machines, and there are several options. And we actually have chosen a two-stage kind of like two-stage deployment. So the first thing that we do is exactly as in the single machine case, we bring up a new machine which we call instance master from our Salt master. So the Salt master is using Salt Cloud to bring up a new machine in an Amazon VPC, virtual private cloud. So we actually also thought about using Syndic, but for reasons that we want to decouple the distributed instance and the Salt master, we decided just to go for a master minion, again with a master and a minion on the distributed instance setup. So, and this additional master on the instance master we use to spin up all the instances which we require for our distributed setup. And this step is also only triggered from the CI. So the CI is not involved into that step anymore. So let's come to the deployment. And one very important point to us was let's separate the steps which are non-critical and which can fail without having influence on the user experience, and those steps which definitely will inflict the user have get an error or something like that. And there are many non-critical steps that you can do first, and then there are some critical steps that you have to do at the end. And that is kind of like the principle of the following two steps. So the first thing that we do is that we again have a Jenkins job. It currently has 3 parameters. The first one is you specify the application version, you specify the software version, which is basically the version of all our third-party dependencies that we are using, and you specify a configuration version. And these versions are set from the Jenkins on the Salt master. And the Salt master deploys the instance master in such a state that it can then, without the help from the CI, deploy the rest of the instance. And that's then the following step. It's again only triggered from the CI, so the CI is not involved in that anymore. and it uses a normal Salt master minion setup to high state, or also there's a bit of orchestration involved, to high state the connected instances and application instances, and it also set up certain Amazon service like elastic load balancing and things like that. Okay. So far we have a static set of application instances, and the nice thing is that you can get as many machines as you want, as long as you pay for them, that's the aim of autoscaling. And with that, you can adapt to dynamically to load. Another thing that is a minor point, but it's not so unimportant actually for autoscaling. If you have a machine that is misbehaving, where the checks fail, an autoscaler will automatically replace such a machine, because typically you scale based on health checks of successful health checks of the machine. So the autoscaler says something like, I want to have 15 healthy machines, and if a machine dies or does not respond, then it gets killed and replaced by another one. And there would have been two approaches. One would have been to just use Salt for that. That would be the completely platform agnostic choice. But we just took the standard Amazon way, because it's very simple, and second, it was also quite easy to integrate it in the setup that we had at that point. So now the activation step has actually some sub-steps. So what we do is instead of configuring a set of application machines, we just configure an application template machine, or if you have many applications, many application template machines. And from these you create an image. So in Amazon terminology, it's an Amazon machine image. And these you can then use, these you can then feed to your autoscaler, and the autoscaler will attach them to the load balancers. And what you also can do in that step is, reconfiguring third-party service or for example, Amazon-specific service. We're using Elasticache for some caches instead of our own Redis, and that can be also set up in that step. So one problem we came upon is that we are deploying from Munich to North Virginia, so it's 7 hours by plane, and it's a pretty long round trip time. And the more Salt we added, the more files we actually were copying in the first step, in the provisioning step of the instance master. And this step, just the file recurse at the end, took something like 2.5 minutes. And the reason is that it just, in a serial fashion, basically asks for every file, do I have the right version? No, okay, pull that file for the next file, and so on and so on. And then we thought, okay, I mean, we don't really need that connection that much. And there's a very nice thing in Salt called Salt SSH, which exactly solves that problem for us, because we don't need that permanent connection. And Salt SSH works completely different. It logs into the target machine. It checks what are the grains, what pillar would I need for that, and then it packs up everything locally that would be needed, pushes it to the target machine and executes it. And with that kind of change, which was actually something like 2 hours or so to move from a master minion setup to Salt SSH, with that kind of change, we brought down that step from 3 minutes to 17 seconds. So the one button solution, let's assemble all the steps that we have so far. So they are triggered by a single Jenkins job. And let's assume that we have a completely empty Amazon VPC, so no machine is deployed. And we want to deploy a new distributed test instance for a new feature, or you have an idea how you can optimize certain kind of database arrangement or whatever. And you can do that by the first. The first job is just creating the necessary machines. And this is a transient Salt container, so we just throw the container away afterwards. The next step is provisioning the instance master. So that is now using Salt SSH and is not using a persistent connection anymore. So we can again throw away our Salt container afterwards. The step that then follows is the activation step. here the CI is not involved, it just waits for the result. And if that is successful, a backup is restored, again, via some orchestration and Salt SSH. And in total, we have something like 15 jobs involved in that, and like half an hour, typically, depending a bit on how quickly Amazon can provide you with new resources, you have half an hour later a completely new instance of your application with a production dump restored or a certain test dump restored, and you can play with it. Yeah?
So my question is about the Salt SSH versus the Salt Master and Minion. So you're sort of just like kicking the problem down the road, right? So with the Salt Master and Minion, you've got, you are confident that they talk, like you accepted the key on the master, the minion's key, that sort of thing, right? So like, how do you now manage SSH keys with Salt SSH?
Okay, so the question was, when you have a Salt Master and Minion setup, the keys are basically set up via Salt, while when you have when you're using Salt SSH, then you're basically relying on SSH public key-based authentication. So what we do there is we use Salt Cloud. And we have a deploy key in Amazon anyhow, which we need to use for Salt Cloud. And that key we use to replace the key on our first deployment. And we also, so we pass some directories, for example, with secrets in those containers with the required secrets. And there, for example, are also the SSH keys which are required from the CI or from the Salt, from that Salt installation. It's not a Salt master anymore, but from the Salt installation to connect to the machine.
So with your Salt Cloud, like bootstrapping, you're providing files in that initial setup.
So with Salt Cloud, we install Salt already on the machine, but we're not installing a specific SSH key. So that is done from Amazon already. So when you specify a key on Amazon, so it basically it replaces the login key with the one that you specify. Yeah. Okay, so lessons learned in that phase was when you can experiment a lot. The nice thing is that you can find out about what scales and what does not scale so nicely, because you can quickly try out a different setup. Yeah, and that's also important that you learn about that, and you need a distributed setup for that. Another thing that we came across quite often is that Salt is definitely more an ops tool, and integrating that into Jenkins is sometimes a bit difficult. So a problem that we had quite often is that Salt by default, or the only option is actually that it returns 0 when the Salt command itself was successful. But what we want to know is there any minion which returned where a state failed, or where a state could not be compiled or something like that. And we did a lot of parsing on the output of the Salt command to get to a non-zero return code, which can then be interpreted by Jenkins, and actually makes the job really also fail, so that also following jobs would not be triggered anymore then. And then what is also really, I think, important, we had a lot of discussion about if we should do that, but if you do deployments frequently, then it's a pain if it doesn't run reliable. So you make it reliable, and vice versa. If it's reliable, then it's easy and no big pain to deploy frequently. So this is kind of like a thing which I really think is one should have in mind. If one increases the reliability of the deployment, then I think a big barrier for deploying frequently is taken. Yeah, so let's come to the last part. So the automating also the infrastructure setup was actually motivated by a requirement that we got. We wanted to separate testing and production. And for those who know a little bit about Amazon, so the only sane way to do is to use a third Bastion account, and from this Bastion account access the two other accounts. So that's a setup that you find quite often in the AWS world. So for this we had to migrate to 3 separate accounts, and since we had to set up the infrastructure anyhow again, we decided, okay, let's do it automatic. And yeah, we thought quite a bit if we should do that with Salt or not. And yeah, Salt was quite nice to do infrastructure setup and reconfiguration during deployment, and it was also quite easy to embed that into more complex deployment. But we felt that for static infrastructure it's not so suitable. And the main reason is we have something like 200 resources for a single application, for a single application instance around our deployment, which do not change. So mainly security groups, but also a lot of rights and roles for certain parts of your infrastructure. So we try to restrict those as much as possible, and then the number, of course, is also gets quite large. And yeah, so also the dependencies are quite many. So yeah, and then we decided, okay, let's try out Terraform, and we're really happy because it really adds up very nicely to the Salt part, and it's yeah, it's perfectly suitable for this task of configuring static infrastructure. And the main difference to Salt is that it keeps track of state. So while Salt, when you do a file.manage, if you do that state, then it doesn't care if somebody has modified the file or if it has been created before, something like that. It just brings the file into the final state. And Terraform actually remembers which resources it did create, and also, of course, depends on that state, so it can also be a problem. But in this case, it is an advantage, because if you then delete a resource, for example, you delete a DNS entry, you can just it will just on the next run also remove that resource. Also in the same way with all the dependencies, because very often if you have a VPN gateway or something like that, you can only remove it if you remove another resource and so on. And it does it it plans itself. It makes a plan where the order is in such a way that the resources really can be removed. So you don't have to implement the reverse way when you're removing a resource. Okay, yeah, lessons learned with Terraform is it's a pretty new tool, so you should, if you want to use it, check out if it has the resources that you really need, and also if the, sometimes tiny details of the resources are already implemented. It's also developing very fast, so it's also, worth probably to take a look on it from time to time. And also here, what is more or less standard when you're using Salt, modularization is key. So with that, you can easily keep testing and production in sync. Okay, some remarks and conclusions. So the first thing is imperative versus declarative configuration. So imperative configuration is very often much easier to implement. I mean, the only thing that you need to do is you need to write a series of idempotent commands, basically. But it has one downside. When it comes to debug a very complex, complex deployment, then you may not find the right spot where it actually fails. So you might first find a successive command which relied on a change before, and there a state is much nicer because you typically have a dependency of states, and if these dependencies, if a requirement is not met, then you just go to the first point in the chain and you will you debug that one. And one thing that we always had to get rid of a bit is of this CMD run shell out thingy that you very often do, because that's actually kind of like an imperative mix-in into your declarative state tree. And this causes a lot of problems because people are swearing on, oh, why is Salt taking so long and whatever, and in reality you have a CMD run state that just hangs because it can't make a connection via curl to some machine or something like that. So avoid CMD run if possible. That's definitely something that we really had to learn. There are also, of course, some points where you can't really avoid imperative configuration. So in particular, when it comes to asynchronicity, where you want to optimize your flow, where you want to make your deployment as compact as possible on a timeline perspective, then sometimes imperative configuration is easier. Another thing is how you distribute knowledge in your team. And the first picture here stands actually for two things. So we started with 2 consultants and are now 15. And second, we have right now more or less 2 people, 2 of us really have in-depth knowledge of Salt and Terraform. And yeah, it's sometimes a bit difficult to find the right balance there because I mean, at least for us, the focus is from the things that we have to do is definitely front-end development. But in principle, we always aimed at keeping deployment as accessible as possible so that everybody can actually do the deployment. So our daily deployment is typically just done by the person who is first in the office. And that's typically not me and my colleagues, so it has to be reliable. What also really helps is if you check your code into Git alongside with the application code, because people can just search through the code base and by that get a rough idea on how things work together. And talking to your colleagues, if they tell you, this really sounds a bit complicated, should sometimes at least make one think maybe there's a simpler solution, and we did that also quite a lot, sometimes that you evolve a Frankenstein solution somehow, and then a colleague of you says, do we really need that? And then you find a way on how much more elegantly do that. So, yeah, finally, as somebody more from a software development background, it was already cut a bit in the keynote this morning. When we write code, you test your code, right? So the code, typically, you write automated tests and you make those reproducible. And you do code reviews. You read code from your colleagues, you argue with them if the code is well written, if it's maintainable, if the quality is okay. And yeah, this is more or less standard, I would say, in most software development branches. So if it comes to infrastructure, it's very often not the case. So the code is not reviewed, so it's not really automatically tested, and thus it's also very often broken. So it's in many projects that I know, the deployment basically runs on a machine where the one who deploys doesn't know in which state it is, and that's the problem. And I think there's no excuse anymore. I mean, we have the tools. I mean, Salt is an excellent tool to solve exactly that problem, and we just have to advertise it more, that it's used, and we can fix this problem with tools like Salt and automate deployment way more than it's typically done nowadays in most cases. Yeah, and with that, thank you for listening, and of course, I take questions, yeah? Yeah.
When you guys had problems with the return codes, did you actually have to go in and modify Salt code to get it to do what you wanted, or did you?
Yeah, so the question was, when we have problems with the return code, how we basically, if we had to modify Salt itself, or how we solve that issue. So what we did is we just wrote a shell wrapper basically around Salt, which we call safe Salt wrap. It's a terrible name, but what it basically does, it just fires up, so it tees the output to a separate file so that you have it in the file that you can afterwards check, and then we check for things like, I think, state compilation failed or some grep magic, it got adapted several times to really catch all cases, but right now it's working quite reliable. So, and the nice thing is that we did not have to modify Salt. Yeah. Over there.
You said you fire up that instance master, and you said that the instance master is what's actually provisioning the rest of the AWS resources around it?
Yeah, so the question was, we fire up the instance master, and if we, with the instance master, configure the rest of the resources in AWS. And that's exactly basically how we did it. So the following steps, which is, I mean, here I described it as a single activation step. Actually, it's, I think, at least 5 steps, which partly also run concurrent, and there's one critical step at the end. These steps are all independent of the CI. So if the connection is lost or something like that, we don't care. It runs AWS internally then. Yeah, over there.
When you're building your infrastructure in AWS, are you destroying your foundational stuff like your VPCs and your security groups and recreating those automatically as part of your deployment, or that's kind of static so that you move around and you deploy into that?
So the question was, if we recreate for a distributed application, do we destroy the static parts like the VPC and the security groups and all that things? And actually at the beginning we did that. So before we had also automated that part, what we did is we had a VPC for production and a VPC for testing. So if we needed to roll a testing version with a different setup of DBs or something like that, or different replication setup or something like that, we cleaned out the old one and deployed a new one into the testing instance. What we can do now is we can just create an additional VPC out of such a Terraform set. So it's just some parameters. We need a different IP range because we connected via VPC to the via VPN to the office. So I think it's like 4 or 5 parameters. We create an empty VPC with all the security groups and that stuff set up, and then we deploy into that security group with a normal deployment, which first creates a machine and all the other stuff subsequently then. Okay. Yeah, no more questions. So, yeah, thanks.